slides are up. Well, welcome everybody, and thank you for coming. I'm the Director of Product Management, so I look after our Kubernetes and our containerization investments here at Red Hat. I have a group of product managers. The closest product manager lives to you is Duncan Hardy, sitting over here, so definitely use him as your community grows here in this area. You know, before I got into OpenShift 4, I'm going to talk about how we sort of make and take Kubernetes from upstream and move it into OpenShift, because in talking to a lot of local customers, there's some confusion around there, so I figured I'd make some graphics up last night. In general, every release of OpenShift is about 4 sprints, and those sprints are about 3 weeks long. So, you know, give or take 5 to 4 sprints. It's a pretty quick release cycle. And when you hit this burn down of bug areas is when we start planning the next release. So pretty much you have 3 releases before you're thinking, or 3 sprints before you start thinking about the next, what should I be working on in the next release cycle. Right after the feature burn down is where we're going to get into deploying what we've been working on in the starter tier. So if you use OpenShift.com and you log into our starter tiers, you can hit that code and you can start feeling those user interface changes and some of the underpinnings change on you. And then we go ahead and we GA that out. Now, what does that mean to the Kubernetes that we're taking? We take straight Kubernetes. There's no modifications. There's no weirdness that happens. We take what you would be taking if you were taking upstream Kubernetes, and we pretty much do 2 rebases in any given release. Now, when you look at our rebasing, because we're in a QA cycle and because we have a lot of other dependencies on us, we start cherry picking after our second rebase. So if we cut on, you know, let's say we're on Kube 1.11 and we took Kube 1.11.2 from the upstream, from that point on, we would be watching the rest of that Kubernetes update stream until we released, and we would be taking the best fixes and cherry picking them back to that particular release. So we could continue our QE cycle. Now, if we do find bugs, we put those bugs back into the upstream first. So we have to go all the way to the top of the head. If at this point in time it would be at Kube 1.12, we'd be putting our fixes in Kube 1.12 and backporting them back to the release of the rebase that we took. So it's always straight Kubernetes, it's always straight open source, it's always what you can find. Now, what the fun part about that is the floor is always moving on us, right? These are containers. And the RHEL operating system is constantly fixing CVEs and constantly rebasing. So we're rebasing on those RHEL things as our development processes go through. We also have a very large catalog of middleware and a very large catalog of just runtimes and application frameworks that we offer CVE protection for. So we're constantly building those as we're building these releases. As our development teams go through their week cycles, they are using containers as well to progress their code that they pull from GitHub and they start building. So all in all, between all of that construction, we build 400 containers a day. Every single day at Red Hat, we are building 400 containers to make this OpenShift product. So when people want to go and just take that upstream Kubernetes, there's a lot of work that goes along with doing that. And this is the value that we add and we bring to you when we say enterprise Kubernetes. So while we're doing that, every card-carrying Red Hat employee that works in OpenShift contributes to upstream Kubernetes. That is where they begin their day. That is where they end their day. And we, from that, carve our OpenShift experiences. And it's working out pretty much. You can see as Diane pointed out, we are the 2nd largest contributor still, so very active. We're doing a lot of cutting wood and carrying water in that community. As Brian also pointed out, we also lead a lot of the SIGs, and we don't pick these at all. What this is a representation of is you. So when our customers ask us questions, when our customers have escalations, when our customers have RFEs, we push our engineers into these areas. And you can see where our customers are pushing us. These are production topics, right? These are authentication, these are storage, these are networking. These are real problems that our customers are pushing us towards. Now, besides just straight Kubernetes, there's also quite a bit of integration and value add that we layer on top. When you install OpenShift, you get a sophisticated network integration with your edge networking, right? Those routing APIs. You get application deployment patterns that are very unique towards enterprises. It's not just simple 3-tier apps. It's not just simple microservices. We get very heavy stateful applications that we're putting a lot of code in and around. We have a lot of default security. We have a lot of default Jenkins integrations. So there's a lot of coding that happens there to integrate this solution to your enterprises themselves. And that brings us to 4. Right? So we always have to be innovating. We always have to be looking ahead, but we always have to listen to what our customers are telling us and allow that to shape us in a very open manner. So what are the things that we're listening to for? The first thing was over 1,000 customers. So globally at this point in time, we have over 1,000 companies deploying OpenShift 3. So it's a really great population and place where we can pull a lot of information on how we want it to shape us. 32,000. That's a number of support cases that came in on OpenShift 3. So these are questions that customers had. These are issues that they had. Wherever the case may be, there's a lot of communication happening over the life course of 3, and there's a lot of value that sort of comes from that. 17,000 commits that Red Hat engineering gave back to the Kubernetes community. That's quite a lot of code that is moving back and forth between that community and OpenShift. 500, over 500. So these are paying GPS engagements on OpenShift globally. So in a given year, we do about over 500. Corporate 100, corporate 2,000, top 3,000 companies, all using OpenShift, all having our staff, our consulting staff, helping them and shaping how they want to do their IT. All of that gets pulled back into the product itself. Brian mentioned we had 11 releases. It's actually 122 releases when you look at it from the engineering point of view. So whenever we hit a Z stream, whenever we create a patch, that's a new branch that we maintain on the OKD, on Origin itself. And so far, there's been 122 releases that we've done of Kubernetes. Over $250 million that we spent on acquisitions. So we purchased CoreOS, but right before that, we also purchased CodeEnvy to help our developer experience grow a little bit faster. So quite a bit of cheating. You know, when we acquire the technology, we bring it in and we open source it and we give it back to the community like Red Hat does with all of our products. Over 400 per day. So these are pods that our customers are launching on OpenShift.com. Over 4,000 applications are launched every day. So that shapes the product as well and our operations staff and what we need to enhance in the product itself. And that brings us to the themes that we decided to invest in 4.0. And when we take a step back and we decide, well, where should we put our R&D dollars, we came up with these 3 buckets for this go-around. Quite a bit of not complaining, but problems around the upgrade. And we'll get into that. So we knew we had to tackle that. We knew we had to tackle, you have the cluster up, how do you maintain that cluster? How do you make them less fragile? We realized that we were going into an era where we were gonna have less massive clusters and more smaller clusters. And we needed to spend some energy around helping people own those clusters. The immutable infrastructure. So when you take a step back, this design premise of what you're using today in OKD and Origin and OpenShift started in 2015, the end of 2014 into 2015, and then we launched at the end of 2015 and the beginning of 2016. At that time, how many people were using Kubernetes? I mean, how many people even pronounced Kubernetes correctly? It was a new world, and so we had to design an installer that allowed you to do whatever you wanted because we didn't know whatever you wanted to do. And that's what that Ansible installer does. It allows you full, complete customization, and it imposes itself on the system. It isn't built into the system. And you see a lot of other things like that. You see Bosch, you see a KubeSpray, you see just a lot of those types of installers doing that. We realize that when we go into this next generation, when we're being compared to EKS and AKS and GKE, that won't work. That's not scalable. That's not foolproof, if you will. So we needed a lot of work on that, and that brings us to this immutable infrastructure. where instead of doing RPMs all the time, instead of installing files on top of systems, we could cheat. We could bake things into images, and we could start orchestrating images if you allowed us some access to those infrastructure APIs. And that's really brings us on par with some of those user experiences that you're having. And then the operator framework itself. And this is not only for applications, which a lot of people, their mind automatically goes to ISV, over-the-counter applications, runtimes that you're writing that you want to deploy on top of the cluster once it's up, and then help you with day two management of those applications, like backing them up or re-indexing them or keeping them healthy. We actually did that, but we also applied that to the framework components itself. So we took Kubernetes itself and we broke it up into 42 different operators. So the Kube API, the storage plugins, the network plugins, all those components are now operators that run. And we can look after those. We can look after the day two management of the system itself through the operator interface. But it also allows us to really bring that system online in a more truer fashion where we can get less confused of the different components. So OpenShift 3, we didn't really help you with the operating system. We didn't really help you with the skew that could happen. You have to carry two maintenance cycles. When you patch OpenShift, there's patching of OpenShift, and when there's RHEL CVEs, there's patching of RHEL CVEs. A lot of people are not happy with the two maintenance windows. Are you happy with the two maintenance windows? No? So we had to fix that. And the way we fixed that is making a more API-driven connection between this layer. So we redefined where the system begins. We go down to the operating system and we say, we will help you own that if you allow us. This is a choice that you're allowed to make. And don't be afraid, because immutability doesn't mean static. And I'll show you how we pull that off, how we work with these configuration files, and how we allow you to have a lot of control and freedom while still living in an immutable world at this level. So let's spend a little bit of time on this, because you're going to hear these phrases quite a bit in the 2019 and this year. One is user provisioned infrastructure, and the other is installer provisioned infrastructure. Now, just like the table says, when you look at OpenShift 3, the default was the user, you provisioned your infrastructure. You went to AWS, you went to Azure, you went to Google Compute Cloud, you logged into their consoles, you created the VPCs, the subnets, the gateways, the NATing, you did all that work. You created your scalar groups, you created your AMIs, you imported those in. That was you owning the infrastructure. In 4, we give you a default option of allowing our installer to do that for you. So we've grown quite a bit. We have over 1,000 customers. We've spoken to them. We think we understand how they're using a lot of the infrastructures out there. And we think that if you're a customer that wants a one-click install, if you're a customer that wants to embed it into a CI/CD process to automatically get a blind cluster and start doing some coding around it, we can stand up that infrastructure for you. Now you can see here it says default, and we still have the option for the user provision. So we also understand that there may be some customers that buy third-party stuff that's really funky, that they've maybe taken the RHEL operating system and now it's their own operating system over the last decade of changes. You can still use your RHEL. You can still use your RHEL 7, your RHEL 8. You can still build your networking and your subnetting if you want. All we ask is that you let us do that for the control plane at least, because we can at least help there. You can allow us just those 3 nodes. Just give us 3 nodes and allow us to connect the networking. And then you can do the rest of your cluster if you must. But those are the options. This is a huge benefit to you. We encourage you to take the installer provision path. Just as a gut check, how many of you would think you would use the installer provision path? Yeah, quite a number of hands. That's great. So let's look at what you can do today. And I encourage all you out there to go to try.openshift.com. You're just going to click this Getting Started. You'll log in. If you don't have an account, create an account. All we say is that we'll do a better job than Facebook at protecting your privacy. Now, this will take us to cloud.openshift.com. In 4.0, cloud.openshift.com, and we may change it before we GA. We're planning to GA in the first half of this year, so right around the end of this calendar quarter, the beginning of next calendar quarter. But this URL is going to become more important because as you install your clusters, you'll have an option to send telemetry back to Red Hat. And the telemetry that you're sending back is pretty much anonymous, but we're looking for how much memory, how many cores, how many operators, are they healthy, those types of statistics. But another aspect of that is you can also use this as almost a SaaS portal to see your clusters. So after you install your clusters, you can come back to cloud.openshift.com. You'll see the name of the cluster. You'll be able to click on them. You'll see a little dashboard of some Prometheus attributes. And you'll also be able to administer your subscriptions. So here you can go and apply subscriptions to clusters or not subscribe clusters to clusters. This also allows us to get into auto-scaling those clusters and making it easier to deal with auto-scaling with our subscription management policies. But you can come here today. You can download this installer binary. It's a Go binary. It's about 250 meg. It's got Terraform embedded into it. This is the interface that you'll use from now on. It's called OpenShift-install, and it replaces some investments that we had made previously in Ansible. Ansible's awesome. We loved Ansible, don't get me wrong. The issue was more of almost a philosophical system issue, right? If you are always sitting on the outside of the system and you're always imposing and controlling state, things can change within that system. The infrastructure can change. The different components of Kubernetes themselves could start acting odd, and that could cause what you wrote from the outside to misbehave. And we had quite a lot of that going on. So we needed to gut what we were doing inside the cluster and move them all to operators, have a sort of an API relationship between them, where if one was not started, the other would not start it, and let the system control that. And that allowed us to survive a lot more variety underneath us. So anyways, that's why we move over to using this approach. After you download it, what it'll look like is this. So you'll get... and you'll just do create cluster, right? If I can type. It'll ask for a key. This is the key that it's going to be using for the operating system connections. So if you wanted to then do an SSH out to the Red Hat Core OS in this case, that is the key it would use. This is where we'll list all the platforms we support. Over the course of 2019, we'll be adding more and more platforms. So if you go to the dev preview right now, it's AWS that you'd be selecting. You'll select your region. You'll select your domain. You'll select a name for the cluster. You'll select a pool secret. This pool secret, when you go to that, cloud.openshift.com, we give you the download for this installer, and then we also give you the pool secret. So what's that doing? That's the easy case, right? You're just answering those. But what if you wanted to tweak it a little more? If you want to tweak it a little more and see what's happening under the covers, you can look at some of these files. So you can look at the install-config file that it is generating. And you do an ls, and we can look at that YAML. So this YAML is what we will use to explain what we're asking for, right? This would be under platform, you'd see AWS. If you had different instance types for the workers as opposed to the masters, as opposed to the infrastructure nodes, this is where you would explain that. If you wanted to use a different SDN, if Nuage or Tigera, you would declare that here. So these are where a lot of the options would be captured into this YAML file. Some other things that happen here, we'll get them generated. All right, so now we have a more full directory. So what's going on? Let's look at this in a slide picture. So when we type that OpenShift install, and it generated this install-config, what ends up happening is we trigger Terraform. So we're using Terraform to stand up 4 nodes. And after that, we don't use Terraform at all. We don't use Terraform as a state engine. We can pretty much use whatever we wanted in this area, but we decided to use Terraform. That brings up a bootstrapping node. And this is a temporary node. It's not there forever. It also brings up 3 master nodes. And what we're doing on that bootstrapping node is we kick off a systemd file. It runs a service called the bootkube. And bootkube is an open source project under Kubernetes. You can check it out. You can use it. But what this does is it tickles the kubelet. So in the operating system image, we deliver cryo. So we switch to using the cryo runtime. And in the operating system image, we bake the kubelet. So that's there. That's almost cheating because it's all already in the image. We don't have to deliver that. Then we have bootkube stand up the etcd cluster. So we have those 3 master nodes. We get a 3-node etcd cluster. And we're using Podman to bring up those etcd containers. The next step is to then bootkube pulls down this cluster version operator. And this cluster version operator understands to call back to quay.io, where we store a lot of our information, and start asking the questions of what's the most available OpenShift. Can I download that? Can I pull that down? And when it pulls it down, it starts creating those manifests that we generated here. So the ignition, so that bootkube, if we check out one of these, so ignition, what it's doing is it calls back to also quay.io, and it pulls down some containers. So when Red Hat CoreOS boots up, it broadcasts, hey, I need some identity containers. You give me something so I know what I'm supposed to be doing in life. It pulls down these files, and these files tell it what to lay down on the file system. Ignition, think of it as a alternative to a cloud init process. It comes up very early in the boot process before systemd starts and allows you to configure that operating system. So it's pulling down those files. That's how we get those 3 masters, and that's how we get the etcd up, if you will, getting those things out. The other thing is the manifests. So if we look at, we won't get into that. So I don't know if you realize this, but there's something called static pods in Kubernetes. You can place in etc Kubernetes manifests different YAML files, pod specs, pod configurations, and without a master, without a control plane, you can ask the kubelet to launch things for you. And so we take those manifests that the installer generates. Now, the installer had to generate those manifests because it had to know what the user was going to ask, like AWS, what instance types, things of that nature. From that information, it derives these manifests, it downloads these manifests into this directory, and we ask that kubelet that was sitting on that operating system to wake up and start some static pods. And that brings up a temporary control plane. And that temporary control plane is a very simple control plane, right? It's got an API server, a scheduler, the bare bones components of what you need. After that control plane, that temporary control plane is up, we tell the kubelet to attach itself to that temporary control plane. Then we allow the control plane to attach itself to those etcd clusters that we started. And then we tell that temporary control plane to act like normal Kubernetes and deploy another control plane, right? So this is Kubernetes pulling itself up. This is Kubernetes bootstrapping itself up with its own core primitives. So when I have a problem, I'm just still fixing Kubernetes. I'm not leaving the Kubernetes space. I'm using Kubernetes to deploy Kubernetes. After I have that permanent control plane up, I pivot. I tell the kubelet to associate itself with that new control plane, and then I tear down that temporary control plane. And now I'm up. So I've built that infrastructure. I've layered down just 4 nodes with Terraform. And besides those nodes in Terraform itself, we're doing quite a bit. So you end up with 6 running instances on that dev preview. If you just take the defaults, you could go and tweak that file and change the instance types. You end up with quite a bit of networking, right? You got 12 subnets, you've got 8 security groups, you've got 6 elastic IPs, 1 endpoint, some routing tables. We go into the routing domains, we expand that for you. So there's quite a bit of automation that we're taken care of with the Terraform besides those 3 nodes. So now we have it up. That's when we stop doing anything with Terraform. Tons of investments this year in the Kubernetes cluster API project. Has anybody been following the cluster API project? There's a lot of energy in it because it allows you to connect Kubernetes to infrastructures. If you take a step back, what people loved about Kubernetes was the declarative management, right? I could take a pod spec, I could explain how I wanted my application to be deployed, and then Kubernetes would look at my YAML and what's deployed, and if they ever look differently, it would change what's deployed to look like the YAML. I could go in, I could edit the YAML, I could apply the change, and Kubernetes would go change that and do its declarative nature. Why can't I use that same thing with machines? Why can't I create, instead of replica sets, machine sets? And why can't I explain how many machines I want instead of how many replica sets I want? I want 3 machines to always be in this machine set. And then I tell Kubernetes to always go look at those machines and always make sure there's that many of them out there. So once we've got that control plane up, instead of using the typical Ansible and other methods to deploy the workers, we tell Kubernetes to deploy the workers. And that's how we get our workers into the cluster. We use the machine controller API, it uses the cluster API, the machine sets and machine classes, and it asks for the workers to come up and join the cluster. Now this also puts us in an awesome position to auto-scale the cluster. I can use that same technology and that same connection to the infrastructure to add and remove nodes from the cluster itself. So just a massive leap in technology here in that SIG upstream. So if you haven't plugged into it, definitely plug into it. So it's some really exciting stuff. So let's look at the product once we have it up. If you haven't seen the product in a while, we do have a new dashboard out there. Let me get my password. There we go. So if you're in 3.11, you have this already. If you have the latest OKD, these are the first integration points that we made with the Tectonic investment. We brought some of the Tectonic user experience. You know, the interesting thing about acquiring a company is talking to their user base. And we realized that at Red Hat, when we had $1 to spend, we would spend it on a developer, a very specific developer persona. And that developer persona was somebody that spent most of their time in the line of code, somebody that was being paid. Their job was to do Java. Their job was to do Node.js. Their job wasn't to do Kubernetes or containers. That's the user that we were attracting. There is another group of developers, more of a DevOps developer, that are more responsible for not only the application layer, but also some of the stuff underneath it. They own some of the responsibility to the platform. And they want it to be shown Kubernetes primitives, and they want it to be shown Docker files in the user experience. So we bring that in. We merge the two. We have, if you want to be a developer, you can have that experience that you always had in OpenShift, and then we also have these additional screens that show you some of the Kubernetes primitives themselves. When you look at this administration, you'll notice something called a channel. So when we ship 4.0, you as a user will be able to decide whether you want to be on the stable channel or on a fast channel. And the fast would be, you know, a more beta or unstable channel itself. So you'll have that choice within the user interface of which channel you want to attach yourself to. You also will notice that under these configuration settings, this will grow as the beta grows, but every core component of the framework will have a page here, and this is where all those options that you would tweak in Ansible, we now move to Kubernetes configuration files and podspec YAML, if you will. So if you wanted to tweak your DNS, you would come here, and the operator itself would protect you against making edits to it that it didn't understand. It would reject things that it did not understand. So this is how we pull off a blind upgrade, which was the other important thing we needed to solve. So we solve the installer problem, right? We now give you the same user experience of asking for a Kubernetes cluster that you would get if you wanted EKS, AKS, or GKE. It is that plain simple. It's a command line. It brings up the nodes. It tickles the infrastructure. It's there for you, right? So check that off. We solved that. We're ready for the next iteration. The other thing we noticed about our 3.x investments is that we use the same technology for the upgrade that we did for the install. And when you do that, you kind of limit yourself on what you're allowed to do with the upgrade. And that was a design flaw. We realize that now. So now the upgrade is a completely different investment than the install. And the upgrade, the first thing we had to do was get all those components to operators, make them more scientifically configurable. Right now we're looking at YAML for editing, where I can go through your YAML and I can look to see if I'm going to be able to successfully upgrade your cluster. And if so, I can give you a blind upgrade. In production, during the day, you can upgrade OpenShift 4 without taking application downtime. And I will run you through the cycles, and I will circle your immutable infrastructure, and I will get you to the next version. And you can have any junior admin do that. It's not a scientific process anymore that requires a massive maintenance window. So that is a huge improvement. And you'll see these types of settings in this global setting that we're going to be running through and checking out for you during the upgrade itself. On the machine sets, you see the installer created some machine sets for the workers. And when we look at these machine sets, I can come in here and I can just hit this up button, and that machine set adds another node to that set. So I can have machine sets for my Elastic, for my HA proxies, for my workers. And if I ever wanted more, I just come in here and I add more, and it has that profile embedded into it. So when we look at that YAML, this is where we get the instance types and the choices with storage and which availability zone I would want them in. So those types of questions would be declared here in that YAML file. Machines are obviously just the nodes out there. You notice we don't have machine sets for the masters. The masters are special to us. They're not something that you're necessarily going to scale in the same way that the other things scale. And so we don't create master sets, and we don't want you to accidentally remove them either, accidentally taking your etcd cluster itself down. And I think that is the big things. The other thing to notice, operators are built on CRDs. If you're not familiar with CRDs, it's a custom resource definition. This is using Kubernetes primitives to watch things that are running on Kubernetes and taking actions that are custom, that are sort of a custom resource definition of what you want to have happen. We've written a ton of them in 4.0 for all the framework components that we're watching for you. This is what you would do with your applications if you were to choose to run them on OpenShift and you want to do some day 2 management of them. So here's a list of all the ones that come out of the box right after an install. And you can see that we're doing quite a bit of investment. If you've been following us with your local sales reps, you'll realize that we've delayed the release of OpenShift 4. So we were targeting December timeframe. We moved that. We're targeting April right now. And it was this particular work that we sort of underestimated. Moving all those Kubernetes framework components and all the configurations that we still wanted to honor that you're allowed to configure in Ansible and still bake in some checking and some knowledge to give you that blind upgrade experience was a massive task. And we run them over 30 engineering Scrum teams. Each and every one of them are working on this. They're working on writing operators for those core Kubernetes framework components and giving all that back to the community itself. So I think that gives you a pretty good picture of the biggest change. Obviously, there's a lot of other awesome things in OpenShift 4. We'll use other common events to dig into the other things. But thanks for the time, and we'll have questions later in the Ask Me Anything session.